All right, chapter 8. So chapter 8 talks about networking. Networking is one of my favorite subjects. So let's see what it says here. Okay, let's look at the summary first. All right, so let's get a summary. What we're going to look at in this chapter. Where's my highlighter? So understand what the common options for internet access, right? All the different ways that you get to the internet. Dial-up, DSL, cable modems, fiber optic, satellites, cellular, radio frequency. All the different options for getting on the internet. No, we're going to look at everything. Know the 5 networking devices. Telephones, switches, routers, firewalls. We're going to see things like DHCP, DNS, wireless security on your phone or at home when you're on wireless. There's all kinds of security that's attached to that. Yeah, it talks about key protocols. We talked about this a little bit before, right? HTTP, you guys remember that, May? HTTP, HTTPS, when you know if a website is secure or not, right? And then, you know, a few other things here. So, well, let's go to the first question and see what the question look like. So, May, I'm going to go to you first. Question 1: you are configuring a computer to participate on a network. Which of the following are mandatory? You are configuring a computer to participate on a network. Which of the following are mandatory? You have IP address, default gateway, DHCP server, subnet mask. So let's see what all these different terms are, right?
Mm-hmm.
IP address. Well, I think we might have looked at IP address before, but let's look at it again. Let's see what it says here. All right. 1 second. Okay, IP addresses. So right here it says to communicate on a network, what is referred to as a TCP IP network, on a network, each device needs to have a unique address, right? A unique address. A unique address. Every device that needs to be on the internet, right, that needs to communicate, needs to have a unique address, which is called an IP address. So, May, do you know where to find your IP address on your computer?
The control panel. And then.
Well, this black box here, this right here.
Mm-hmm.
The command prompt.
Command prompt.
So if you go to your command prompt, right, and what do you type? ipconfig. You open up your command prompt, you type ipconfig. You hit enter, right? You hit enter, ipconfig. You hit enter, it's going to show you a whole bunch of addresses on your computer, right? You're looking for something that says Ethernet adapter, right? Ethernet adapter, Ethernet. Ethernet adapter, right? And then you're looking for something that says IPv4 address. IPv4. Okay? IPv4 address. Now your IP address is going to look something like this, right? Or something like this. It's the way you say the IP address. For example, this IP address is 192.168.168.56.1, right? And there's always 4 groups of addresses. Like 192 is the first group, 168 is the next group, 56 is the next group, and this is the 4th group. So it depends on what your IP address is. This is another IP address here. It's always 4 groups, 4, right? 169.254.119.149. Okay? There are 2 parts. There's 4 parts to your IP address. And that is referred to as the IPv4, IP version 4, right? The version is version 4. We have version 6, but that's not so common yet. IPv4 is very common. And we all have, every computer, every device that needs to communicate on the network has an IP address. So it's a unique address, right? Your IP address is for you and you alone, or for your computer, let me see, for your computer or your device. It's kind of like your social security number or your driver's license number or your school ID. It is for you and for your device and just that device. Every device you have in your house has a different IP address, right? So every device, if you have a laptop, a computer, a phone, whatever, tablet, they all have unique IP addresses. Because the IP address is how you get information. In fact, the IP address, let me pull this up here. So let's say computer IP address, right? It's like your home address. Compared to your home address, something like that, right? You can compare it to your home address. If I want to send you a package, right? I need to know your name, your address, your city, your state, your zip code.
Mm-hmm.
So I put this package and I send it to you. Your IP address, actually, believe it or not, it tells us not your actual address, but it tells us your area, your zip code.
Mm-hmm.
Right? Your IP address tells us your zip code, what area that device is at. Right? So if I, for example, if you do a search and say, what is my IP address? Well, this is showing my IPv6. What I want to see is my IPv4. So if I go in here, it's going to do a check. Let's see what happens here. So it tells me that my IPv4, you guys can see this?
Yeah.
Okay. So it tells me that my IPv4 address is 73.4.129.241. Now, it's going to tell you where I'm at. Based on that IP address, it tells you that I'm in Watertown, Massachusetts, right? and it tells you that my ISP, my internet service provider, is Comcast. So your IP address will give us an idea of your geographical location, your zip code, right? Or depends on where you are, but wherever you are on Earth, wherever you are in the world, right? Your IP address, if you have the right tools, will give us an idea of where that message is coming from. Now, people have a lot of ways to disguise or hide their IP address, but with the right tools, you can have an idea of, it's not going to tell you your house address, right? But it will tell us the area, that from this area is where that device is at. Like right now, you can see that I'm in Watertown, but it doesn't tell you my street address or the number of my house. You know what I mean? That's how it operates.
So
just go ahead.
Yeah, I have a question. Is that every computer or have different IP address?
Every device, every computer, they all have different IP addresses. Yes.
So even you in the home, you use the same Wi-Fi, same internet, but the IP address different.
Okay, that's a great question. Let me jump ahead and say that IP addresses, right, have two parts. They're two IPs, sort of, right? We have what we call the public IP. We have a public and a private IP. So all the computers in your house, if you do a Google search of what's my IP, right, it's going to show you the same IP. In fact, if all the computers in your zip code, right, like in my zip code, a lot of people use Comcast, right? Now, all these people are going to have the same public IP address, right? Public IP, because Comcast is the provider for everybody. It's like in my zip code, when you write a letter, we all have the same zip code address, right? Because we live in the same zip code. But every house has a different number. So your computer, if all the computers in your house or all the computers in your zip code, if they belong to the same ISP, will have the same public IP, but your private IP is going to be different. So if you look at all the devices in your house, right, and you look at their IP configuration, you're going to see, for example, you can see that right here, it doesn't tell you that my IP is 73.4.129.241. You see that here? It tells you that my IP is 169.254.119.149. Actually, I'm not even sure that's my IP. I think my correct IP, no, this is my correct IP right here, right? This is my correct IP. Now, this IP, 10.0.0.112, is a private IP. The IP you see right here, that's a public IP. All the devices in my house all have different IPs, private IPs. We have the same public IP because we belong to the same, obviously to the same ISP, but our private IPs are different because when communication is just like your mail, right? Just like your mail. When mail is going back and forth, of course, when mail is coming to your house, it just comes to your house, right? It doesn't matter if it's for the dad, for the mom, for the kids, it just comes to your house. But when it comes to computers and devices, every computer and device is unique because every computer sends information out. So if you're on your phone, you send out a text message. If you're on your tablet, you might be on Netflix. If you're on your computer, you might be doing some schoolwork. Every computer, every device right, is sending out a unique message. So they need to have different IP so the message can come back. So we're going to get to that very soon. But the way it works is your private IP not seen from the So if somebody tries to look for your private IP, they're not going to see your private IP from outside. The only IP that people can be seen from the internet, right? Anytime people want to look for your IP, they're never going to see your private. Oh, what am I doing? I think I made a mistake here.
What?
Yeah. So this is public.
Private.
Okay, and this is private. Yep, private. Okay. So anytime people look for you, because people always ask me, so can anybody just hack into my computer and find me? It's not so easy, right? Even though if you have some very good tools, right? From the public, when people look for your IP, they're going to see the public IP address. So your private IP is never seen. So what happens? There's something we call NAT, and you're going to see that in this chapter. It's called where is it? Network address translation, right? Now, it's a big word, but what it does basically is it takes your private IP, right? When you want to go on the internet, it changes your private IP to a public IP. And when that message is coming back to you, to your device, it changes it from a public IP back to private. It's like it's a security feature on the internet. So your private IP is never revealed. So when I Googled my IP, this is my private IP, but the IP you see here is my public IP. So May, your question, if you look at all the devices you have at home, you're going to see that they all have different. You might have 10.0.0.112, 113, 114, 115, something like that, right? But your public IP is probably going to be the same if you're all on Comcast or Verizon or whatever it is, right?
So that's mean if we have a couple of devices, couple of computers, the private IP is going to be different?
It's going to be different because every computer, every device, every phone, every laptop, every tablet, they all send messages right from that device going outside, coming back. So each of those devices has a different IP address. In fact, if they have the same IP, there's going to be a problem in that network. There's going to be a conflict. Something's going. Verizon or Comcast has to come and fix it. So that's not how it's designed. Every device must have a unique IP. All right. Okay, let's move on. So that's what your IP is, right? Like it says here, any device with an IP address is referred to as a host. It can be servers, workstations, printers, routers, whatever. As long as it has to communicate somehow on the network, it must have a unique IP. All right. So like we said, it looks like this. That's an example. 192.168.10.55. Right. That's how you write it. So like we said also, the version is IPv4. The newer version is called IPv6, right? But it's not very common yet. They're still working on it. Okay? All right. Let's go back to that question and let's see what else it's asking us for. So it's asking us about IP addresses, asking about default gateway. So let's see default gateway here. All right. Okay. I'm going to try to do this. This is like, I spent the whole semester teaching this topic. I got to teach you guys in 1 week, right? So let me try. All right. Where's my, I think I have something, where is it? Let me see if I have it here. Right here. Okay. All right, this is a good picture. So let's look at this picture. Try not to be scared or like, oh, what is this? This is confusing. Just take a deep breath, like, okay, calm down, right? So let's just say that this might be maybe right here where you have H4, H5, H6. Oh, actually, this is network 1, right? How should you see this? Network 1, network 2, network 3, and network 4 right here. Okay? So network 1. So let's say network 1 here. Let's say this is couch. This is your house, right? You have 4 computers. Network 2, that is May's house, right? There are 3 computers there. Network 4, that is Alex's house. He's got 2 computers there, right? Now, this is just a diagram, right? But when you see a network diagram, it's called a network diagram. Network diagram, okay? In a network diagram, round objects, oh man, I am typing badly. Round objects are routers. Okay, so let me explain. So this objects here, right? Now, they're not actually round in the real world. In the real world, they just look like regular computers, right? But here's what's going on. So this is couch, network 1. This is network 2. This is May's house. And network 3, this is Alex. Now, if you want to send an email from network 1 to network 2, or network 2 to network 3, right? That message is going to go outside your house, right? Before it can get to network 2, it's like if you send a letter, couch, from your house, an actual letter, right? From your house to May's house. Well, it has to go through the post office, right? Someone has to take it, right, and deliver it to that other address. Now, in networking terms, that post office is a computer device called a router. Now, I know that at home, right? At home, you have what you call a router. So, home router. So at home, everybody has, some kind of router at home. Well, that's a router, but technically, this is not a router, technically, but I'll just allow it to be. Because everybody says, oh, I have a router. So, no problem. But what I'm talking about is not your home router here. I'm talking about a bigger device, right? A bigger computer whose job it is to move messages from your home or your office or your school or your computer, wherever you are, to another computer that is totally outside your home or your office or your building, right? And that's what we call a router. It connects, it sends messages between 2 different networks. So your home is a network. Your home is a private network. Your friend's home is a private network. Even if you're going across the world, you're sending something from here to India, that is still a private network, that person's house, right? you have a router. Of course, you have multiple routers, not just one. Depends on how far it is, right? You're going to have multiple routers that take the message and pass it on from one router to the next router until it gets to its destination. That is how the internet is designed, right? You have computers that take the messages and send it along until it gets to its destination. It's kind of like if you're traveling, right? You're traveling from here to India, or from here to China, or from here to Africa. Sometimes you might go through different, you might have different stops on the way, right? Maybe you get to a different country, then you have to change the plane, then you get to a different country, you have to change the plane, then they stamp your passport, until you get to, you might get to 2 or 3 different destinations before you eventually get to where you're going. In networking, the guys who do this kind of immigration work, kind of like immigration, right? They're called routers, right? And so every time you send a message from every time you use your computer to go on Amazon or to go on Quincy College or to send an email, you're sending messages from your computer to another computer somewhere. And we have routers whose job it is to route the message to the other computers or the other networks, right? So now what we call default gateways, this word here, default gateway, right? Basically, the gateway is the router, right, that is kind of like in front of your network. The router that takes your messages and sends it along, that's your default gateway, right? So every time you're sending stuff out, you're using your computer, email, you're shopping or whatever it is, your router, so in my case, right, in my example, my router is going to be with Comcast. So every time I'm going to do anything on my computer, Comcast has to send that message to wherever it's going. So Comcast has a router in my area or for my area. I don't know where it is. It may not be in my area, but it's for my area, right? Am I making sense or am I just confusing you guys? Everybody's quiet. Am I making sense, Lynn?
Yes, yes.
Yeah.
So, right?
Not too much, but okay.
Well, like I said, the router is just a computer device. You don't see it. It's with Comcast or with Verizon or AT&T, whoever your provider is, right? It's like the post office. When I send a message, it has to pass through the post office, right?
Mm-hmm.
Yeah, it has to pass through the post office. Then the post office looks at the address and says, okay, it's going to California, or it's going to Worcester, it's going to Charlestown, it's going to New York. So your router is the post office that sends the messages where it needs to go, right? So that's what you call the default net, just like the post office in your zip code, right? That is the router, right? Comcast, Verizon, whoever it is, that's your default gateway. I'm just trying to see as much as possible that you guys get it. Okay, let's go to the next option there for that question. Okay, DHCP server. What's DHCP server? Let's see what it says here. Okay. So the DHCP server is kind of very close to the router, kind of close to the router, right? The job of the DHCP server is right here to provide IP addresses to every computer in that network. So, Ling, for you to get on the internet,
Mm-hmm.
right, there is a DHCP server,
Mm-hmm.
right, from your who's your ISP? Is it Comcast, Verizon, AT&T? Who gives you internet?
I don't know.
You don't know?
You need to pay for it.
And it's not my job, it's my husband's job. So I
Okay.
don't know.
Yeah, but come on, Lynn, but you should know. Is it Comcast or Verizon? You mean you just use the internet, you don't even know?
Yeah.
You have to call your husband and say, how do you say in Chinese, what's our ISP? How do you say in Chinese?
Might be Xfinity.
No. I want to, how you say it in Chinese? Like who is the ISP?
Okay, I don't know.
In Chinese, what? ISP?
How do you ask your husband in Chinese? Who is our ISP? Who gives us internet? How do you ask that in Chinese?
Oh, in Chinese,
Yeah.
网络公司是哪一个?
Okay, that's pretty long for me. Okay, well, make sure you ask your husband, is it
Okay.
Xfinity or whatever it is, right?
Okay.
Wow. Geez, you don't know who your provider is. Lord have mercy. Okay.
I never paid the bill, so I don't know.
Okay. Do you eat rice, Lane?
Huh?
Do you eat rice or noodles?
Rice?
Okay, where do you get the rice from? Do you know? Or your husband just buys the rice?
Oh, that's going to supermarket. But
Who go? You go or your husband goes?
But I spend my husband's credit card. I never get the money for bank.
Oh, so who buys the rice? You or your husband?
I buy the rice, but use
Okay.
my husband's credit card.
Oh, okay. Well, when we're done with this class, maybe you can go and get your own job and have your own credit card, right?
Yeah.
Okay.
Yes.
So your provider, Xfinity, Fios, Comcast, Verizon, whatever it is, right? They have a Dhcp server whose job it is to make sure that all your devices in your house have IP addresses. All right? The Dhcp server is just a computer that's, at Verizon or Fios or whatever it is, right? But that device, its job is to make sure that when you connect to that network, right? Like I said right here, the Dhcp server can be configured to provide IP information automatically to clients, right? The following configuration information is typically provided. So it gives you an IP address, gives you what you call a subnet mask, a default gateway, and a DNS server address. This is all information you need to be on the internet. Okay? Let's see the last part of that, the last option there. Subnet mask. Let's see what that is. Subnet mask. Okay. All right, right here it says, look at this here. Computers are able to differentiate where the network ID ends and the host address begins through the use of a subnet mask. So basically, your subnet mask it's attached to your IP address, to your network, right? So you have your IP address and you have the subnet mask. The subnet mask, it's kind of like, I think a good definition is, if you own your own property, right? Or let's say, your apartment where you live. Let me show you an example here. All right, so look at this here. Oh, let's say fence. Where is it? Okay, well, maybe this is a good example here. Maybe it is. Usually, some houses have a fence around it, right? This is a. Okay, let's just say that. Some houses have a fence around it. So you want to know this fence is where you have your property, right? When your neighbor builds their house, they can't extend to your property. So the fence basically tells you this is your property. So in a sense, we can say that the subnet mask, that's what it does. It tells you where your network starts and ends, right? Different from somebody else's network. That's what it says here. It's able to differentiate where the network ID ends, right? So maybe that, and then it has a set of numbers. The numbers usually will look something like this: 255.255.255.255. Right? Now let me say this because you might be wondering. I'm sure we're going to look at it. You know, how do you come up with these numbers with all these IP addresses, right? You might be thinking about, you might be asking that question in your mind. You know, are these numbers just random numbers, right? 10.0.0.112, 255.255.255, 192. Are they random numbers, Anu? What do you think? Where do all these IP? How do we come up with these IP numbers?
Oh, they are not random numbers. Maybe some system will designate that. Or
okay, so there's a system, you know, that gives out IPs. There's a kind of system. It's not just any crazy combination of numbers. There's a certain system. We're going to look at that system in a little bit. But it's not just random numbers. They look like random numbers, but they are not random numbers, right? Each of these numbers means something, right? It means something, right? In fact, just to give this to you right now, IP addresses, let's look at this here. 255.255.255.255, right? IP addresses can never exceed, that is, each of the four groups, right? The four numbers can never exceed 255, right? So the maximum number or the highest number for each of the groups is 255. So it can be, so each of these groups can be anywhere from 0 to 255. Each of those groups. Now, usually you wouldn't get to 255 because some numbers are reserved for, you know, computer, for special purposes. So we can say maybe like from 10 to maybe 250. All the other numbers are probably reserved. Okay. But I'm going to explain that when we get to that point. You know. So, May, let's see if we can answer this question now. If we kind of talked about it a little bit. So the question was, you are configuring a computer, right, to participate on a network. Which of the following are mandatory for that computer to be able to function on a network? Any idea?
Yeah, I know IP address.
Okay, you certainly need the IP. Yep.
Yeah. So the other ones, I think it.
Okay, default gateway, like we said, that just tells you, you know, your router.
Mm-hmm.
It just says the router.
Mm-hmm.
The DHCP server its job is just to give you your IP address. The subnet mask, it tells you where your IP address starts and ends. So the subnet mask, it goes along with IP. When you have an IP, you absolutely must have a subnet mask.
So A and D.
Yes, A and D.
It's like the subnet mask is the boundary for your network, like your fence around your house, if you have a fence. If you have a house, if you're not homeless, like living under the bridge. Just kidding. Actually, that's not funny because some people actually don't have a house. So, okay. So, May, it's A and D. Should we check? Let's check, right? Question 8. All right, so it says an IP address and a subnet mask are required, right? Are required for you to communicate on a network. Okay? DHCP automatically assigns IP and your gateway is your router, basically. Okay? So A and D right there. All right, Lynn, you're next.
Which one?
Which one of the following types of network connections can give you the highest data transfer rates? The highest, where is it? The highest data transfer rate. What am I doing here? Okay, so we talked before, Lane, if you remember, about data transfer, right? If you guys remember that, talking about bits, bytes, megabytes, gigabytes, terabytes,
yes.
petabytes, zettabytes, exabytes, right?
Yes.
And we said that when you talk about data transfer, right? Data transfers how? Bits per second, right? Bits per second. Bits per second. How many bits can you transfer in a second, right? So if you have 1,000 bits, right, 1,000 bits, and you have, let's say you have a device that can transfer 100 bits per second, right?
Mm-hmm.
So your device can transfer 100 bits per second. You have 1,000 bits. Well, what's the answer? Lynn?
One.
You just divide. 1,000 divided by 100 is what?
10.
Yes.
Exactly, Anjuman. It's 10. So if you have 1,000 bits and you want to transfer and your device transfers 100 bits per second, that's going to be 10 seconds.
10 seconds, yes.
Right? 10 seconds, it's all transferred, right? So right here is asking, it says, which one of the following types of network connections can give you the highest data transfer rates? Okay, the highest. So let's take a look at this here. So let's see T1. Okay, so right here, it tells us about different types of networks, right? Right here it says, you have all these acronyms, like right here, it says you have LAN. When you might hear LAN or WAN, okay? A LAN, a local area network known as a LAN, it's a small network, like the network you have at home or you have in your office or in a classroom. A small network referred to as a local area network, okay?
Mm-hmm.
Then you have a bigger network, which is made up of many LANs, right? Many LANs. Right here it says that when you have so it's called a WAN, right? Wide Area Network, a WAN. Now it says right here, a WAN configuration usually spreads across multiple geographical areas, maybe across the city of Boston, across Massachusetts, right? A very large area, maybe across the United States, across a whole country, right? Usually you need a router because you're going from one network to another network, right? When you're inside one network, like at home, what you use to transfer information in your house is a switch, right? We'll talk about that later. So we say right here, let me close this. So let me go here. LAN connections use switches. WAN connections use routers. So in your home, right? Your home is a LAN. And when we go back to this picture here, right? This device in your home actually works as a switch. So every time, so your computers in your house can communicate with each other, right? The job of the switch, when a message comes into your house, let's say you send an email, you're waiting for the reply. When that reply comes into your house, the switch sends that message back to your computer. If somebody else in your house, maybe sending a text message, they're waiting for the message to come back from the other person. The switch, its job is to direct the messages to all the different devices. So in a LAN, switches send the messages, the connections. In a WAN, use routers because WANs are much bigger areas. Use routers. Okay? So right here, the WAN, then it talks, so we go down here to the T1. What's the T1 thing we're talking about just right now? Okay. So right here it says in a wide area network, look at this here. It says, so you have what you call a T1 connection, right? That runs at, it's a different type of internet connection, basically, right? Called a T1. It runs at 1.544 megabits per second, right? Megabits per second, 1.544. Then you have ISDN, which can be really slow, 128 kilobits per second, pretty slow, right? So T1 is 1.544, ISDN is 128 kbps. Then we look at the other two. Where's the other two here? Where's it? DSL and Cellular. So DSL. So actually, let's put it down here. So T1, 588 megabits per second. Mbps. What's the other one? ISDN
is 128 kbps.
Kilobits per second. Let's see DSL and Cellular. All right, so DSL is what? DSL. So DSL is what most people have at home right now, right? Most of us use DSL, high speed, right? That's what we use right now. It says one of the most popular broadband, right? Broadband fast internet is digital subscriber line, DSL. DSL for high speed access. So let's see the speed of DSL. Let's just say the speed here. Okay, look at that. So if we look here, it says the first time in 1998, the speed was 8 megabits per second. Right now, it says you're going to see 30 megabits per second. 30. So 30 megabits per second, right? Megabits per second. So let's see cellular. For cellular. What's the cellular speed here? Okay, cellular here, that is cell phones, like when you're on the road and you try to, use your phone and stuff like that, right? Let's see the connection speed. Okay, right here, so look at this section. It says, well, when you had 3G, right? You had 3G, it was 500 kilobits per second. 4G gives you about 10 to 20 Mbps, right? 10 to 20. So, yeah. So I guess we're going to go with that 10 to 20 megabits per second.
So answer is DSL.
Really? How do you know that?
Because 30 Mbps.
I thought you just guessed the answer. It's right there, right?
Every time I guess.
Yeah, so high-speed internet, it's the most reliable and the fastest. This is actually 588, I think. Yeah, DSL. All right, so that's DSL right there for the answer. With this. All right, next question. Kaush, are you still there?
If you are configuring a wireless router to let clients get on the internet while using private IP addresses, in this scenario, which of the following services do you need to make sure is enabled on the router?
Okay, 1 second. So we already talked about DHCP, right? DHCP basically makes sure you get your IP address. That's all it does. Okay? Now, we talked about, oh, where is it? We talked about, let's talk about DNS. Let's look at DNS for 1 second. DNS. All right, DNS. Okay, so DHCP and DNS. Where's DNS now? Okay. Right here. Okay. DNS has one function on the network, and that is to resolve host names. Resolve host names to URLs to IP. So let me explain what that is, right, Kaush? So let's say you want to go to, Quincy College. .edu, right? Oh, Quincy College. Okay. So you go to your browser, right, and you type in quincycollege.edu, okay?
Yeah.
Or maybe for your kids, you go to where? Right? SesameStreet.org or something, okay?
Mm-hmm.
Now, when you type that in your browser, the browser, if I type in Sesame Street here, boom, it shows me a picture of Super Elmo, right? And Cookie Monster, right? And all this and all this interesting people here, all these interesting characters and monsters, all right? Okay, now, how did this browser find the website? You know, how does this browser find the website? You know, computers don't understand English or Chinese or Pashto. Is it Pashto, right? What's that? Pashto is that a language in India or in Pakistan? Does anybody know this language here? Pashto? Is it Pashto or Pashto?
That is not
Hello?
from India. Not from India.
Not in China, I'm sure.
Yeah.
Oh, wait a minute. I want to find out.
Okay. Maybe where the
Oh,
another one.
Pashto.
Oh, okay.
Oh, that's Iran. That's in Iran.
Iran.
Okay, that's in Iran. Okay, in Iran. You see, I was kind of close. I was close. Okay. So the computer doesn't understand, you know, human languages. So what the DNS does is you have a database. It's like a, you know, DNS database. In that database, it looks like this, sort of like this. In that database, it looks something like this. Website, IP address. So it looks something like this, right? Where is it? So let's say you have a website. What's this website here? SesameStreet.org, right? Now, computers only understand numbers, IP addresses, right? So when you go to SesameStreet.org, believe it or not, this is a web server, a computer. This website is on a computer. It looks to you like a website, but in reality, it's just it's just website files on a web server, right?
Yeah.
It's like if I go to my, you know, I go here. I think I've showed you guys before, and I open up. I want to design a web page, and I say, was it H1? H1 right there. Now I can put this up here. Oh, not that. What am I doing? Got the wrong thing. Why do I keep picking up the wrong thing here? Not that. Okay, this is what I want. Okay. Now, if I design this website properly, right? If I design this website, it can look like a very fancy website. If I want to put Elmo's picture, right, I can say, where is Elmo's picture? All right, that's Elmo's picture right there. I'm going to put the picture on my fake website that I'm trying to do right now. So, right here. I'm going to grab that and put it on my website that I'm trying to design. Okay, right here you can see this is my website, right? Elmo is right there. It's too big, too big. So I'm going to make it a bit smaller on my fancy website. All right, see that? You guys seen this?
Yep.
Yes.
So if I design this website, right, and I design my files, I can publish my files to a web server. When I'm done with the whole website, it's going to look like a fancy website. You know what I mean? So a website is just basically files on a web server. So here's my point about the DNS. So every website, right, every website is on a web server. That's a computer. For your computer or your browser to communicate to that web server, right, it needs to know the IP address. Your computer's IP talks to the other computer's IP address. So let's just say the IP address is 122.56.23.22. Doesn't matter. I don't know what it is, right? Let's just say that's what it is. When you type in this website address, right, the DNS server, the DNS is Domain Name System, DNS. The DNS, right? The DNS system is going to look for the IP address of that website, and when it finds the IP address, then it sends it to your computer. So every website, if we have a lot of websites here, every website that we have, right, all the websites, they all have different web addresses. You know, just different websites have different different IP addresses, right? So the job of the DNS, the domain name system, is to find when you type in the. You know why this happens? Because human beings, we don't remember a lot of numbers. We remember names, but not numbers. Alex, how many contacts do you have on your phone? Do you know? Like how many?
I don't know, but if I don't
like
look,
20, 50, 100?
maybe not more than 50.
Okay, let's say you have 50 contacts on your phone. How many phone numbers do you know in your head?
Not more than 5.
Okay, right? So human beings, we're not very good with remembering numbers. Well, you can remember names. So when you store a number on your phone, you say Uncle George, right? Or you say Professor, or you say Mark at Dunkin' Donuts or something. You use all these names that you can remember. But the DNS system, its job is to find the IP address of a website and send it to your computer. That's what it does. So right here, that's what it means here, Kaush, by the DNS has to resolve the host name, right? The website address to the IP address, right? If the DNS doesn't do that, you're never going to find the IP address. So it works on the back end to do that kind of stuff, right? So that's DNS. All right, let's see what else. Let's see the other question here. So DNS, I told you about NAT already, NAT, right? The NAT system, Network Address Translation. Okay, so Network Address Translation. The job is to translate your private IP to a public IP when you're going to get on the internet. So there's some kind of a security involved, right? Your IP is never revealed to the world, just your public IP, right? And when you're every message, if you have the right tools, every message, every email, every text message, every time you go on the internet, every time you go to Netflix or you go to Facebook or whatever, every time you go online, your IP address is attached to whatever you're doing. Your IP address, right? If you have the right tools, you can look into those messages, right? Not very easy at all. You need to be very skilled and experienced, all right? So network address translation is a system on the internet that translates your IP to your private and public IP. Now, the last option there is APIPA. So APIPA right here, this option, APIPA, APIPA. So what is APIPA? It says that APIPA right here, automatic private IP addressing, right? Now, remember how we said, what we said about DHCP, right? We said that DHCP's job, do you guys remember? DHCP gives you IP addresses, right? Gives you IP addresses in your network. That's part of your ISP, Comcast, Verizon, Xfinity, whatever. So DHCP gives you an IP address when you want to be on the network. But sometimes there is no DHCP, right? DHCP. Sometimes there is no DHCP. Let's say, for example, right now, let me get this. If I disconnect from the internet, right, and if I connect two computers directly together. So I disconnect from the internet, but I use this cable to connect two computers. Not on the internet, just direct connection, right, Alex? Now, those two computers, because I have this cable, those two computers can communicate with each other. Not on the internet, just, you know, between themselves. For that connection to happen, they need to have an IP address. So that's what I mean by there is, you have DHCP when you are on the network, when you have internet access, right? Let me just say that basically, when you have internet. But when there's no internet, but the computers are connected, there is no DHCP. But the computers still need an IP address, right? So when you connect to computers directly, there's no internet, just a direct communication. Those two computers still need IP addresses, right? The whole system of the internet has what we call APIPA. APIPA is a reserved set of IP addresses that your computer automatically, right? It automatically generates an IP address for itself. When there's no DHCP, but there's a connection to another computer. Sounds confusing, but your computer is designed when there is no internet, but it's connected to another computer, it's going to get its own IP from inside its own system. Alex, does it make sense to you? It's a bit confusing, right?
It sounds really confusing because we cannot imagine a computer not using the internet nowadays.
Yeah. Well, computers were not always designed to just be on the internet. Sometimes, for security reasons, you might decide, I don't want to be on the internet. I'm going to connect all these computers in this room. These computers can talk to each other, but not go on the internet. For some kind of, maybe for privacy, or it depends on what you need to do. Sometimes it's a security move that you make. So when you have no internet, but you connect some computers together, those computers will generate their own IP addresses. That is where you have APIPA coming in, right? Automatic private IP addresses. Look at what it says here. Used to configure IP addresses automatically that are unable to reach a Dhcp server, right? And they have a range. They start from this range here and 169.254.0.0. That's the range. We'll talk about the ranges in the next class, all right? That's what the APIPA does. So let's answer that question, Kaush. See if we can answer that question. Maybe. Let me get this out of here. So, was it Kaush who had this answer? This question 3, right?
Yes.
So can you figure it out now? Maybe.
Need to make sure is enabled on the router. DNS, NAT, API.
Exactly.
D.
Yep, I think you're right. I think it's this one here. Where is it? I think it's NAT, Network Address Translation, because remember what it says here is you're configuring a wireless router that lets clients get on the internet while using private IP addresses. So with a private IP address, you can't get on the internet. You need that IP address to be converted to a public IP, then you can get on the internet, right? So I know it's a lot because these are courses that we teach for 4 months. Now you got to get an idea of it, you know, in a short class. But all you need to do is just get a basic idea. So when you hear about it, it doesn't sound strange. Like, I have never heard of this before, right? For you to have a little idea of it. So you're right. I think let's check out the answer and then we can do the attendance and I can let you guys go. Question 3. Number 8, question 3. It is, yep, Kaush, you're right. Network address translation is a service that runs on a router that translates IP addresses into public IP addresses. So what? So you can do what?
Private IP address into public IP address. You can
Get
So
on
you
the,
can,
get
so
on
you
the
can do what?
internet.
can get on the internet.
To get on the internet.
Exactly. That's what it does. Okay. That's all we got. Let's do the attendance. And if you have any questions, let me know.
No questions.